Okay, so we're going to jump right in with our graphing of our linear equations. We have two examples here. I'll go ahead and zoom in on one. We'll graph this, then we'll look at the other one. So a couple things I want to point out and identify. Here's our equation. Y equals 4/5 x plus 2. Maybe I'll actually write it off to the side. Y equals 4/5 x plus 2. I want to point out that our x is raised to the first power. That's what makes this linear. I know that this is going to look like a straight line when I graph it because it has an x to the first power. Right below that, I want to go ahead and write y equals mx plus b, just to help show that our slope is right there in front of the x and our y-intercept is right there. So let's go ahead and make note. Our slope is 4/5. Now a positive slope is going to, from the left to the right, look like it's going up a hill like that. So I know my line should look something like that if I have graphed it correctly. The y-intercept is that 2. We can write that as an ordered pair. The x is a 0, the y is a 2. That's an ordered pair. That's a point that we will plot on our graph. All right, so let's go ahead and graph our equation. We start with our starting point, which is the y-intercept. It goes on the y-axis at a positive 2. All right, from here, you do the rise. The rise is our 4. And because that's a positive, we are going to go up 4. 1, 2, 3, 4. And from there, we do the run. Now, I'm going to tell you guys, if you always run to the right, you're going to do a better job graphing these lines if you always run to the right. So the rise, you could go up or down, but always run to the right when you're graphing these points from your y-intercept. So we're going to rise 1, 2, 3, 4, run to the right 5. 1, 2, 3, 4, 5, and plot your next point. And then we just repeat that pattern. I want you to fill up your whole graph. We're going to rise again 4. 1, 2, 3, 4, and we're going to run 1, 2, 3, 4, 5, and plot that point over there. So quick check, I can see that my points are lining up in a straight line. That's a good sign. And I can see going from the left point to the points on the right that it looks like I'm going up a hill. That matches the positive slope that I noticed in the beginning. All right, to get the rest of the points on the left side of our axis, we're going to go back to the y-intercept, and now we're just going to do the exact opposite. You're going to go down 4, 1, 2, 3, 4, and you're going to run to the left 5. Then we'll go down 4 to the left 5. So we just repeat that pattern. Everything looks good, lining up in a straight line, so then we can go ahead and graph our line. We put arrows on the end because these lines do continue forever in both directions. It's not a line segment, it is a line, so arrows go on the end. All right, let's take a look at our next example. We have y equals negative 3/4 x minus 5. Do you guys see this negative that's out in front of your fraction? Anytime you guys have a negative out in front of the fraction, I want you to, when you rewrite it or when you look at it, put that negative with the top number. So I want you to see it as a negative 3/4 x minus 5. All right, let's go ahead and identify our slope and y-intercept. The slope is the number in front of the x, which is a negative 3/4. Now, a negative slope, I know if I'm going from the left to the right, should be going down a hill, something like that. So I'm kind of predicting what this line will look like. The y-intercept is that number on the end, minus 5. And so it is a negative 5. As an ordered pair, I could write that as 0, negative 5. All right, now we go to our graph. We start with the y-intercept. That's our starting point. On the y-axis, we go down to a 5, or we go down 5 to a negative 5 and plot that point. From there, we do our slope. Remember, rise over run. Do you see how our rise is negative? That means instead of going up 3, we're going to go down 3. 1, 2, 3. And then as we are plotting these first points, remember, run to the right. You're always going to run to the right. 1, 2, 3, 4. Plot that point. Look at this graph real quick. Let me show you, why do I say run to the right when you're plotting the points after your y-intercept, if I went down 3, 1, 2, 3, and if I went to the left, 1, 2, 3, 4, what I'd be getting is a line that looked like this, and that line has a positive slope, not the negative slope that we need. So you just want to look out for that. If you always run to the left, or sorry, run to the right, you're going to get the correct uphill or downhill that you need. All right, back to graphing our line. We are going down 3 to the right 4, plotting a point. Down 3, I'm off my graph. If I do want to go to the right 4, I can see it's going to be right about there. Everything's lining up, so that's looking good. Going back to the y-intercept, now we backtrack. This is the only time you run to the left, is when you're going on the left side of the y-axis. So now we're going to do the exact opposite. Rise 3, go to the left 4, and plot your point. Rise 3, go to the left 4. Rise 3, go to the left 4, takes us off the graph. So now we're just going to draw as nice and neat as we can. Arrows on the end, and we have graphed our linear equation.